h of x is defined by h of x is equal to x squared plus 4x plus 3, where x is less than or equal to minus 1, and it's equal to the modulus of 2x minus 1, where x is greater than minus 1. Part A, sketch it. So let's deal with the quadratic first, where x is less than or equal to minus 1. So let me just sketch the quadratic and then we'll worry about the domain in a minute. I can see it's got a y-intercept of 3. Factorising, I'll get the roots. So factorising this, I'll get x plus 1, x plus 3. So I've got roots at minus 1 and minus 3. And if I complete the square, I'll get the turning point. So I would get a turning point of minus 1, minus 1. Sorry, minus 2. Minus 1. Minus 2 from here, minus 1 from here. So my quadratic is going to look something like this. But it should only be valid for when x is less than or equal to minus 1. So I actually only want this part of the graph. So let me rub this bit out where x is greater than minus 1. Right. Let's draw the modulus of 2x minus 1. So I'll draw y equals 2x minus 1 first, and then we'll deal with the modulus in a minute. So y-intercept of minus 1, gradient of 2. So this is what y equals 2x minus 1 would look like. But if I do the modulus of that, that's going to multiply all the negative values, so all of these values down here, by minus 1 to turn them positive. So it's now going to look something like this. So that's the graph of the modulus of 2x minus 1, but that should only be valid for where x is greater than minus 1. So only valid for these values here. So I'm going to rub the other bit out. I'm also going to put a hollow circle there to show that the red line, the modulus graph, is not defined when x equals minus 1. And I'll draw a solid circle down here where, just to signify that the quadratic is valid for where x is equal to minus 1. Right, part B says to state the range. So from my graph, I can see the smallest that y can possibly be is minus 1. Can't be any lower than that. In terms of the biggest it can be, I can see it goes up and up and up there. It goes up and up and up over there. There's no upper limit to what y can be. But the lower limit is certainly minus 1. So I'm going to say that h of x is greater than or equal to minus 1. It can equal minus 1 here because the x can equal minus 2. Part C says to solve, h of x is equal to 8. So 8 on my graph is here. So I can see there's two solutions. There's the solution to the quadratic there, and there's a solution to the modulus graph there, and remembering that this is the part of the graph that was not reflected by the modulus. So that part didn't get multiplied by minus 1. That's the regular 2x minus 1 part of the graph. So let's find when does that equal 8. So if we add the 1 to both sides, so x is 4.5, which does make sense. So that's one solution. Now let's get the other solution, which is where the quadratic was equal to 8. So let's take the x squared plus 4x plus 3 is equal to 8. Subtract the 8 from both sides. And that is going to factorise. We'll have x plus 5, x minus 1. So we'll have two solutions of minus 5 or plus 1. But I'm going to ignore the minus, I'm going to ignore the 1 solution because my quadratic is not defined when x is equal to 1. It's only defined for where x is less than minus 1. So the minus 5 is the solution that I was expecting to get. And then for part D, solve h of x is equal to 2. So just clearing a bit of space here, and then we'll do, let's put 2 onto our graph, and we'll find where h of x equals that. So now I'm expecting 3 different solutions. Let's deal with the quadratic one first. So x squared plus 4x plus 3 is equal to 2. Subtract the 2 from both sides. And that's not going to factorise, so I'll use my quadratic formula for that. So using the quadratic formula, I get 2 solutions. I get minus 0.27 rather to 2 decimal places, or minus 3.73 again to 2 decimal places. I'm going to ignore the minus 0.27 because that is not less than minus 1. That's too big. The function is only defined for where x is x is less than minus 1. And minus 0.27 is not less than minus 1. So I'll ignore that solution. This solution is valid though. That's minus 3.73 there to 2 decimal places. Next, what about this solution here? Again, remember this part of the graph here, that was just the regular 2x minus 1 part of the graph. So that's equal to 2. Add 1 to both sides. So x is 3 over 2 or 1.5, which makes sense. Or it could also have been this one here. Now remember, this part of the graph, that was the modulus that got multiplied by minus 1 when it flipped from being down here to being positive. So if I take the 2x minus 1 and multiply that by minus 1, we get minus 2x plus 1. That's the equation of that line there. So I've just taken the modulus of 2x minus 1, and then I've times this by minus 1, and this by minus 1. And let's now find when does that equal the 2 that we're looking for. Subtract the 1 from both sides. Divide both sides by minus 2, and we get minus 1/2. And so that is the third solution.